So, welcome to our next video lesson. So, for the subject of engineering mechanics, and topic is in continuation to the previous one, that is simple stresses and strains. So, in simple stresses and strains, we have discussed in the last class about stress and different types of stresses. Now, let us see what is today's objectives. So, on completion of this period, we will be able to define the strain and state the different types of strains and define the different type of strains. Okay, of course it is repeated. Okay, and define the different types of strains as well as strain. Basically, first strain, let us start with the strain definition, and after that it is we are going to discuss about the different types of strains. Okay, and after that it is what is the different types of strain. Let us define the different types of strains also in detail. Now, what we have discussed in the last class, just recall whatever we have discussed. So in last class we have discussed about the stress. We have started with the stress definition. So what is stress? So stress is nothing but so just recall what we have discussed in the last class or last lecture class. We have discussed about the stress. What is the definition of stress? Stress is nothing but, yes, the resistance offered by the body against the external loads per unit area is nothing but the stress. The internal resistance offered by the body or a member against the external loads per unit area. And thing is that, so in that one, the internal resistance means it is resistance to what? Resistance to what? So first of all, resistance to external loads. When when resistance to external loads, right? When what happens when external loads acts? When external loads acts, so it try to first deform the member. Okay, there may be possibility of deformation may take place. Okay, right? So against this deformation, right, the member will offer some internal resistance. The induced means that is induced in the member. Okay, internal resistance is induced in the member, right? So that internal resistance we are calling it as a stress. Okay, again per unit area. That's what we have discussed in the last class. And what is the units of stress? So how mathematically expressed? The stress is mathematically expressed as load per unit area or load per area, right? And after that we have discussed about units. So what are the units of stress? Again, it is Pascal. That is nothing but Newton per meter square. How we got? Very simple. If you know the mathematical expression of stress, that is stress is equal to load by area. Load means again force, load or force. So what is the units of force? It's newtons. And what is the area? Units of area? Meter square. So it is Newton per meter square or Newton per millimeter square or kilonewton per meter square or kilonewton per millimeter square, like that. Okay, so that what we have discussed units. And again, different types of stresses means again, and it is depends on how many directions the loads are acting, but the stress and how many directions the stress are developed. So it is one direction, we are probably the one dimension. If it is stress developed in two directions, it is called a two dimensional. If it is three direction, it is called, we are called the three dimensional stress. Again, depends on load, type of load. We are defined the stresses, different types of stresses. That is nothing but tensile stress, right, compressive stress, and tangential stress or shear stress we have discussed about, right? So what is tensile stress? So first of all, before the tensile load, we have need to define. So tensile load is nothing but a load which is acting along an axial load which acts, right, and it is like a pulling the member. Okay, a pull is applied on the member, means it is try to pull the member so that member get elongated, and that type of force are calling a tensile force. And the stress due to the forces, this axial pull means axial tension or axial tensile force, which are acting normal to the cross section. Okay, which are acting the normal to the normal means perpendicular to the cross section, and these type of stresses or resistance due to this type of forces is nothing but we are calling it as a tensile stress. Okay, that is nothing but the resistance induced in the section to axial pull or axial forces, or you can say it's a tensile force acting normal to the cross section. These are called tensile stress. Similarly, we had discussed about the compressive stress. It is a resistance developed in the section to an axial push or compressive load or compressive force acting normal to the cross section. And shear stress are also be called as tangential stress. It is the stress which acts tangentially, means along the surface on a plane due to shear force. On a plane due to shear force. Okay, so that's what we have discussed in the last class. Now let us go to our today's topic, that is the types of strains and strain definition, etc. First, let us define the strain. Strain is a deformation produced per unit original length or unit length simply. Okay, deformation produced per unit original length, or it is a ratio of change in length to original length. Deformation produced per unit original length. Deformation means change in length. Okay, the deformation is nothing but change in length by original length. That's the definition of the strain. The ratio of change in length to original length means if it is, we have seen in the last class, right? So we have seen the last class, that is tensile stress and compressive stress. In that one, after if you have an application of the load, let us say tensile force, the change in length takes place, right? That means it is, in that case it is increased. The length is increased. So that change in increase in that change in length is nothing but we are calling the delta L. The delta L is equal to final length minus initial length. That will give the change in length. Okay, that change in length divided by initial length or original length, that will give the strain. The strain is generally denoted with the letter either small e or epsilon, not e. This is not capital E. There is an epsilon symbol. Okay, epsilon. So it's either small e or epsilon. Generally used denoted with these letters. So that is nothing but strain is equal to E is equal to change in length by original length. Okay, delta L by L. E is equal to delta L by L. Strain is a dimensionless quantity and hence has no units. Why it has no units? See here, strain, what is the definition, mathematical expression of strain? So delta L by L, change in length to length. What are the units of change in length? Either change in length or length, the units are millimeters. Similarly, length units are original length or length units are millimeters, both are millimeters. So both get cancelled. What is the remaining? Nil. So that's why it is nothing but a no units. It does not have any units. The strain is a dimensionless and this unit, no units. Okay. So it is a dimensionless quantity and hence has no units. Then coming to the different types of strains. So just before this concept, I will want to say something. So when a member is subjected to, let us say this is a member. When a member is subjected to, let us say tension, right? So it is nothing but its length is increased. Okay, length increased. So let us say if not like this, so I will try a little bit of different figure so that it will be easily we can understand. Right? Yeah. Sorry. Yes. Let us say this is a one end. So this member is fixed to this one. Okay. So this member is fixed to this one. by some arrangement, right? And it is acted upon by a load, let us say P, right? So it is acted upon by a load P. So due to this application of load, it is like a pull is nothing but tension. So due to this force, what happens? So it will be, there will be change in length. Okay. So initially when load is applied, so let us see what happens initially. So the first, out of the stress and strain, very basic concept, just be careful about it. When a load is applied, initially, because of this application of load, the member may expands or contracts, depends on the type of load. Means change in dimension may takes place. Okay, it tries to, that force will try to deform the body. That different deformation may be anything. That is a different decrease in length, increase in length, change in shapes, or anything. There may be n number of different types of relation, maybe that deformation. The basic is nothing but it tries to deform the body. The force will tries to deform the body. Okay, but because of this, it will tries to deform is nothing but change in dimension, or change in length, or change in two dimensions. There can be different types of changes, either only along the one direction there will be change, and other direction it will be very negligible, or that change in that may be only in two dimensions. Depends on the type of body, type of load. It is there may be different types of possibilities are there, right? So however, that first criteria, what happens, there is try to deform the body. The force will try to deform the body, right? So against this deformation, the member will try to resist, develop some internal resistance. Okay, the member or body develops some, induce some internal resistance is induced nothing but internally developed, some resistance is induced in the member against this deformation, right? Have you understood? Yes, this see the sequence. So when a load is applied on a body, that load will try to deform the body first, right? Try to deform the body. Due to this deformation, what happens? Due to deformation, what is happening? What is the first criteria that will the member is subjected to? Strain, right? The member first, because of this external loads, the initially the member is subjected to strain. Strain is nothing but deformation, right? Deformation may be possible due to, if at all that member is capable of that load or resist that load, it's nothing but, resist is nothing but, there may be some internal resistance is induced, or resistance is induced in that member. Okay, resistance is induced in that member. So resistance induced is nothing but, what is it? Resistance, internal resistance. Internal resistance against this applied loads per unit area, we have discussed in last class. Yes, that is nothing but stress, right? So these are the very fundamental two very definition, very fundamental. So be careful about it. So when is applied, what is the first one? It is takes place either stress or strain. Stress or strain, which one will first comes? Yes, it is subjected to first initially the strain. The member is subjected to strain. Okay, to avoid this strain, or to take care of the strain, there will be some, the body or the member will offer some internal resistance. Okay, so if it is having some resistance, then it offers, okay, that resistance whatever offers against this deformation due to applied loads, that we are calling as a stress, right? So we are discussing both at a point. See, so far in up to in last class we have discussed stress. Now initially first slide we have discussed strain. Now I am putting together so that you can understand the concept in a better way, stress and strain. right? So that's what is happening when a member is subjected to load. Not only a tensile load, it may be compressive load, it may be some combination of loads, bending and shear, twisting, anything. There can be combination of loads also. So anyhow, but initially whatever the type of load, that may be a compressive load, that may be tensile load, that may be shear, that may be a bending, that may be of course bending as always accompanied by shear, right? And twisting, so different, any type of force, right? So that's what this basic concept of stress and strain. So once again I want to clear. So it's nothing but when a member is subjected to external force, the first one which develops is nothing but strain. And after the strain, then comes the stress, right? Of course, this is already we discussed. Now let us go to the types of strains. So according to the type of the body on which they act, according to the type of the body on which they act, means it is subjected to what type of stress. And what type of body means if it is one dimensional, two dimensional, three dimensional, it is just like what we have discussed in these types of stresses: one dimensional, two dimensional stress, three dimensional. Here also one dimensional, three dimensional, three dimensional. According to the nature of the stress of the body, it is subjected to, means based on type of loads it is subjected to. If it is subjected to tension, tensile strain; if it is compression, compressive strain; if it is shear force, then it is subjected to shear strain, right? And if it is subjected to from the all directions, it is nothing but a total load from the all directions, and it is nothing but volumetric strain, right? Now let us discuss one by one. First one dimensional strain. It is the strain developed in one direction, right? And it is also known as uniaxial strain. Uni means one, only one direction. Strain developed in only in one direction, right? See, one dimensional, because in this is nothing but where is the examples for we can think very possible that it is a very long member is there compared to other lateral dimension. It is very long. It is some long, any load is applied, tension is applied to that load, like a wire ropes in electric poles, like that. So there is possibility of only it elongates along the direction of the load, and its lateral dimension is very negligible, right? So that type of members may subject to this type of strain, right? So very length only in this direction. There may be lateral deformation is not there. So then only one direction there may be possibility. Delta L. But the strain in this case, strain is equal to delta L by L. Two-dimensional stress. It is a strain developed in two directions. It is also known as biaxial. So it is nothing but this is a body. So it is one direction delta L, another direction delta B. Along the length direction delta L, along the width direction delta B. Along the two sides, there is change in dimension is there. Okay, along the two directions, like a plate elements. Okay, so compared to like a two-dimensional body, the other third dimension is very negligible. So that's why the only two directions there may be a considerable amount of deformations are there along the length direction as well as along the width direction. Okay, so if it is here in this case, it is strain along this direction is called delta L by L, along this direction delta B by B. Okay. Next, third one. So three-dimensional strain. It is a strain developed in the three directions. It is also known as triaxial strain. It is also known as triaxial strain. So it's nothing but three-dimensional strain. You see this one? All along the three dimensions. So this is along the length, and this is width, and this is height. All along the three-dimensional, all along the three directions. The member is there is a change in size, or change in length, or change in dimension, or deformation takes place in all three directions. Okay, the member is deforms in all three directions, along the length, along the width, along the depth or height. Okay, that type of strains we are calling as a three-dimensional strain. In this case, along the length it is delta L by L, along the width it is delta B by B, along the height dimension delta H by H. Right? Now let us go to the next type of, based on nature of stress. I mean, nature of stress it is developed, and nature of strains it is developed. Type of, based on type of load we can say. Tensile strain. So what is tension? We have already discussed. It's nothing but a pull which tries to elongate the member, is nothing but tension. So because of this tension or tensile load or pull, the bar is subjected to elongation, means the elongates. The bar elongates. Elongates means change in length state space, increases in length state space. Okay, due to this tensile force, the length is increased, elongates. Right? So elongates means increase in length state space. Right, like this. Consider a bar of length L, uniform cross section area A. Right. So it is, this is initial length and this is tension at the two ends. Here in this case, the bar elongated shape and final length is, let us say, L1. Initial length is L and final length is L1. Now, what is the change in length? Change in length is equal to final length minus initial length. So that it is increased more. That's why it is final length minus initial length. So that is nothing but change in length. So the change in length by original length, that will give the strain. If the bar is subjected to a pair of collinear forces P acting in opposite directions away from the bar, means both are away from the bar. If it is away from the bar, it is pull or tension. If it is towards the bar, it is nothing but compression or push. So the force acting on the bar is known as a tensile force or pull. When the bar is subjected to tensile force, the length of the bar increases or tends to increase. Then tensile strain, it is a ratio of increase in length to the original length. It is denoted with either Et or epsilon T. T refers to the tensile strain. So tensile strain is equal to increase in length by original length, delta L by L. The formula will remain same. If it is tension, if it is memory subject tension, then we call it as a tensile strain. Right? If it is compression, compressive strain. Then comes to compressive strain. Right? So bar is subjected to a compression. This is load. See this load. So this is nothing but towards the member. Okay, the load acting towards the member. Away from the member means away from. This is nothing but away from the member. This is nothing but towards the member. Away means like this. Right. So this is away from is nothing but tension. Towards means nothing but compression. So it is bar is subject to compression just before application of force. This is, let us say, initial length is L. Of course, there will be some everything. Yeah. So it is, the initial length is L. Due to this force, what happens? Both are pushing the member. So what happens? It contracts. Okay. Because of this push, the member get contracts. And let us say that final length is L1. Right? Final length is L1. Then what is that? In this case, what happened? Length is decreased or increased? Yes, it is decreased. Okay. In tension, the length increased. In the compression, the length decreased. So what is the decrease in length? Decrease in length is equal to delta L is equal to L minus L1, means initial length minus final length. Right? So it is initial length minus final length. Okay. Then what is the strain? Now let us see. Again, strain is equal to what? Change in length by original length. What is the change in length? Delta L. Delta L is nothing but, so we can write it. So what is change in length? L minus L1 divided by L. So it is nothing but, if you expand, L minus L minus L1 by L. So, or you can say 1 minus L1 by L. Strain is nothing but 1 minus L1 by L. Right? This is nothing but relative. We can say that comparatively how much the change in the ratio of final length to initial length. So if the body is subjected to a pair of collinear forces P acting in opposite directions towards the bar. You see this definition of a compressive force towards the bar. Opposite only, but towards the bar is nothing but compression, and away from the bar is nothing but away or towards. That is, everything is same. The definition is same, everything, except if you put this away and towards. Right? So if it is away from that one, then we call it as a tension, and if it is towards means compression. So that is only change in definition for the compressive force and tensile force. If the body is subjected to pair of collinear forces acting, collinear means in same direction, along the same line of action. Forces which are having the same line of action, along the same line of action, the forces are acting, they are called as the collinear forces. In this case, they are collinear, all are acting along the axis of the member and in opposite directions. That's what it is said, that opposite direction, and away from this, away towards the member. So towards the member, away from the member, towards the member. So it is towards the member means it is a compressive force. When the bar is subjected to push or compression, the length of the bar decreases. Let us say R, not comma, it is R. Subject to push or compressive force, the length of the bar, what happens? Increased or decreased? Decreased. In the case of compressive force, the length of the bar decreases or tend to decrease. Of course, every time it may or may not decreases, but that force will try to decrease the member. Okay, so when it is within its limit, so up to certain limit, it may not be able to any appreciable amount of or notable amount of depreciating change in dimension may not be possible. After certain extents only you can able to see the deformation. But initially it will always try to initially tries. After certain point of time it starts deformation. Right? Then we can see the decrease. Right? That is the meaning of tend to decrease. Compressive strain. So it is the ratio of decrease in length to the original length. Previously, tensile strain is nothing but increase in length to the original length. Whereas in this one, because length is decreased, so that's why we are saying the decrease in length to the original length. That's what the definition of a compressive strain. It is denoted with the letter EC or epsilon C. C refers to compression. So compressive strain is equal to decrease in length by original length. Okay, delta L by L. EC is equal to delta L by L. Now come to the most important thing, that is shear strain. Right? Shear strain is nothing but, if it is a body is there A B C D, right? A body is there A B C D. If it is subjected to some force in tangential direction, if force some let us say, yes, this is a body, let us say this is fixed at this end, for example, and on this top face CD face, let us say it is subjected to some tangential force or shear force. It is subjected to some tangential force. Okay, so what happens, it will try to change its body, means its shape, try to, it is means it is try to pull this top face CD face towards the side, right? Then it is, let us say it is deformed to final position of C1 and D1. Initially it is, its position is CD, finally it is C1 and D1, right? Right, it is final position is C1 and D1. And how much amount of it is change in dimension, it is how much, how much it is change for an angle of pi. Let us say for an angle of pi, this amount of an angle of pi, it is the change in this, it is towards this, it is deformed. So what is shear strain? Let us see now. It is measure of the angle through which the body is distorted by the applied tangential force. Okay, so body distorted. Distorted means the dimension, it is that one dimension is changed. Distorted means it is changed from its dimension, its shape, loses its shape from the rectangle to the like a parallelogram. Okay, distorted, right? It is distorted from its initial one. How much it is, distorted, that measure is nothing but shear strain. Okay, that measure of that angle through which the body is distorted, the measure of the angle means how much angle it is distorted. Okay, the body is distorted for what is the amount of angle, an amount of angle, then that measure is nothing but we are calling as a shear strain. Okay, the distortion is nothing but shear strain. An angle, it is a measure of the angle through which, it is distorted due to this tangential force. This is a Q is nothing but tangential force in this case. Of course, here it is a, so Q is nothing but tangential force, right? If it is obviously when this side Q is nothing but, obviously this side shall be Q force shall be there, right? Q shall be there along this direction also, right? 7 minutes. Okay. So it is, yeah, it is what is shear strain? Shear strain is nothing but it's a measure of the angle through which the body is distorted by the applied tangential force. Okay, due to this tangential force Q, so it is, if it is applied on this one, means it is resistance will be developed. The equal and opposite force will applied here also. So it will be this side is Q, this side is Q, so that definitely the body will be in equilibrium condition. Because of this force, so there will be a distortion will be there, and that amount of distortion is nothing but your shear strain. Okay, so due to the effect of tangential force Q on the body, the end D shifts to D1 and C shifts to C1, right? The strain is deformation per unit length, right? It's nothing but C1 by L is equal to D1 by L is equal to tan pi. So C1 by L and D1 means it is a dimension. If you see this one, yes, it is CD1 by L and CC1 by L, right? Tan pi is equal to CC1 opposite by adjacent side. Tan pi is equal to opposite by adjacent side, right? Opposite means CC1 or DD1. Okay, DD1 CC1 by L. This dimension is L, and this DD1 by L. This dimension is L, right? That's what it is. cc1 by L is equal to tan pi, right? So the angular deformation is usually expressed as in radians. Angular deformation pi is usually expressed in radians. For small values of pi, because this is when a body is subjected to this tangential force, that whatever shear deformation, that angular deformation or shear strain, that deformation pi will be very, very less. Okay, so very less. So that generally that is nothing. That's why it is pi may be tan pi equal to pi. You may refer it as a tan pi equal to pi, or you may consider tan pi equal to pi. Small values of pi, tan pi may be considered equal to pi, right? So that's why it is pi is nothing but we can say that here for small values, what way you can write? So this cc1 by L or equal to d1 by L equal to pi. So this is nothing but shear strain. Shear strain is equal to pi is equal to cc1 by L or d1 by L, right? That's what it is. Small values of pi, tan pi may be equal to pi, right? Now let us go to the next one. This volumetric strain. It is a ratio between change in volume to the original volume, right? Change in volume to the original volume. It's not individually, right? It is not individual change in length, width, and depth. So in this case, it is nothing but as a overall, how much amount of volume is changing compared to its original volume. That is nothing but volumetric strain, right? We are talking about volume here, not individual dimensions. So it is a ratio between change in volume to the original volume. Initially, how much volume? Initially how much volume, and finally on application of the load, there may be different type of, there may be any type of loading. Okay, after loading, if it is volume is decreased or increased, then how much it is increased? That change, that change divided by original, that will give the volumetric strain. So EV is equal to delta V by V. EV or epsilon V is equal to delta V by V. Change in volume by original volume. Again, it has any strain, not have any units. Strain is nothing but dimensionless, so no units. Right. Now let us summarize what you have discussed so far. So far we have discussed in this session, we have discussed about the strain. So what is strain? So strain is nothing but change in length to the original length or initial length, delta L by L. That may be increase in length, that may be decrease in length, whatever the length, the change in length by original length, that is nothing but strain, right? So if it is along the one dimension, it is coming to the types of strains. It is again it is strain is equal to change delta L by L, and it has no it is a delta L by L is nothing but, so L both are millimeters, so it means it has no units. Okay, it cannot have any units, so it is a as it is a dimensionless, right? So no units. Now coming to the types of strains. One dimensional strains means it is the strain developed in one direction, right? If it is in direct developed in two directions, it is called a two-dimensional strain, and if it is developed in three directions, it is called a three-dimensional strain, right? So there is a different types of strains according to the lower directions. Now coming to the other types of based on nature of strain. So nature of strain, based on nature of strain is nothing but tensile strain. It is a ratio of increase in length to the original length. So it is increase in length. So be careful about it. Is an increase in length to the original length. Tensile strain is nothing but increase in length to the original length. And compressive strain. So compressive strain is what? See the decrease in length. You observe what is the difference. Decrease in length to original length. Ratio of decrease. Whereas in this case it is increase. Now in this case it is a decrease. So decrease means in compression the length decreases, In tension, the length increases. Right? That ratio is nothing but compressive. That ratio change in length to original length. Simply strain is nothing but change in length to original length. Whereas in increase in length to original length, tensile strain, decrease in length to original length, compressive strain. And it is shear strain is nothing but it is a measure of the angle through which it is distorted due to tangential force. Okay, so measure of the angle through which the body is distorted, right? That is nothing but we are discussed it as a pi. So through which the angle it is distorted means displaced the surface. Okay, any other, right? Corresponding to the other one, how much angle it is distorted. That is nothing but your shear strain. And the next one is volumetric strain. It is the ratio of change in volume to the original volume. It is the ratio of change in volume to the original volume. Change in volume to the original volume. Right. So now let us see some simple questions like this. The strain developed in two directions is called. So these are the options. So two directions is nothing but two-dimensional strain. The strain developed in one direction is called as a one direction, one dimensional. Two direction, two dimensional. Three directions, three dimensional. Very simple, right? The ratio of decrease in length to original length. What type of strain it is? Decrease in length to what? Decrease means compressive. Next one, the ratio of increase in length to original length. Increase means, so increase means increase in length. For what type of force it is length increases? For tensile forces the length increases. Yes, right. That's why it is in this case. What is the ratio? What is the answer? So it is tensile strain. Right. The finally, what is the shear strain? Measure of the angle through which the body is distorted by the applied tangential force is called the shear strain. Right. And ratio of change in volume to original volume. What it is? Volumetric strain. Right. Now let us see some frequently asked questions. So it is, what is the questions you may get? So very simple. It is a tensile strain, compressive strain, shear strain, and volumetric strain. Definitions of all these things. Okay. And of course, one dimensional. It is of course you might have not in syllabus. So this may be very common. Tensile strain, compressive strain, shear strain, and volumetric strain. So these are the some of the common types of questions asked in the examinations. Oh, sorry.